Chapter 12 has us changing gears, looking at sequences and series. We're going to divide this up into arithmetic sequences and series, and then geometric. First, let's start with arithmetic. We're starting off the lesson with a section of key definitions. The first is arithmetic sequence, a pattern of numbers either by addition or subtraction. Two types of arithmetic sequences that we will work with are finite and infinite. A finite sequence is a sequence that has a start and end value, like the pattern 1, 2, 3, and 4. That would be a finite pattern because it stops at the number 4. An infinite pattern will be noted by the same kind of commas, 1, 2, 3, and 4, but you'll indicate infinite with a 3-set dot kind of pattern at the end of your sequence. So a sequence is any pattern of numbers, arithmetic by adding or subtracting. Finite means the pattern stops. Infinite means the pattern would go on infinitely or forever. To the right, the definition for common difference, that's the number you're actually adding or subtracting by in that arithmetic sequence. For example, the pattern 1, 2, 3, and 4, what are we adding by? That's a comma right there. What would we be adding by? We're adding 1 each time in that pattern. So the common difference is known with a capital D. That's kind of the variable that stands for common difference. In this case, D would be positive 1. Our next definition is called a recursive arithmetic definition. This is the formula that you would use to create your finite or infinite pattern. When you're asked to write a recursive definition, recursive means it's two parts and kind of written in the format I have down below. You'll always write a sub n equals on the left, and n means any term in the sequence. That means a sub n is kind of like your y equals. It's the output value. In the top row, you always write a sub 1, and that's just whatever number your first term is. And that means n would equal 1 after that comma. In that second row, notice how I've written a sub n minus 1. Notice that n minus 1 is lower. It's like a subset number. A sub n minus 1 plus d. So n minus 1 means you're looking at the previous term. Whatever the number is in that pattern, to get that next term, you add that common difference to it. This rule applies for everything greater than 1. So everything in green is what you would have for your answer when asked to write a recursive definition. The other formula that we can use to create an arithmetic pattern or sequence is called the explicit arithmetic formula. This formula is much more efficient. A sub n equals a sub 1 plus d times n minus 1. There's no sub values on this one other than the a sub n and the a sub 1. You can use this formula to find any term in your sequence. If you know a sub 1 and you know d, you literally just plug them into this formula and simplify. Let's take a look at a few examples. Given this sequence 3, 8, 13, 18, 23, is this sequence arithmetic? Which means are we adding or subtracting the same thing each time? Take a look at those numbers. I would say yes. We are adding 5 each time to go from 3 to 8, 8 to 13, and so on. Anytime you're adding or subtracting, it's arithmetic. Question B, what is the common difference? So what is the difference within the numbers? Well, if we're adding 5 each time, that literally means D equals 5. That's it. What's the next term in the sequence? If we're at 23, and we follow our common difference rule of adding 5, the next number would be 28. All right, write a recursive formula. Recursive is that two-part formula for finding the next term in the sequence. To write the recursive or explicit formula, we need a sub 1, that means the first term, that's 3. And the common difference, we know it's plus 5, so it's positive 5. To write the recursive formula, this is that two-part formula. So we write a sub n equals, and then we do that brace symbol. In the top row, we write out what a sub 1 equals, and that's 3. And that's when n equals 1. That just indicates it's the first term. So this just means a sub 1. In that second row, we said to take a sub n minus 1 plus d. We leave a sub n minus 1, that means the previous term, and then we add d to it. So we're just going to do plus 5. And this rule will work for anything greater than 1. Okay, so if we have a sub n minus 1, that just means add 5 to the last term in order to get the next term. All right, let's convert this and try to find the explicit definition as well. To find the explicit definition, we need the same things, but our formula is just going to look a little different. We still need a sub 1, and we still need d. Those two values stay the same. The explicit definition just has us go right to that a sub n rule with only one row. A sub 1 plus d times n minus 1. All right, so based on this, I'm going to distribute the 5 in to get rid of the parenthesis. And that would give us 5n minus 5. Combine like terms, they're on the same side. So this would be a sub n equals 5n minus 2. That formula will also work to get you any pattern in that sequence. Given the explicit definition, a sub n equals 16 minus 3 times n minus 1, what is the recursive definition? Taking a look at the template, a sub 1 plus d times n minus 1, this would indicate that a sub 1 equals 16. That would be the value of our first term. D is actually negative 3. That means we're subtracting 3 each time instead of adding in our pattern. Just writing that in for a little extra info. To write that recursive model, remember by definition, the recursive model is the 2-row model for your arithmetic definition. So we do that big brace on the left. In the top row, we define a sub 1, and we've set it 16. So that's when n equals 1. That means the first term. In the second row, we take the previous term, that's when we write that a minus 1, and we just add d to it. But d is negative, so technically we're just going to subtract. And that pattern rule works for any term that's after 1. And that's writing the explicit and recursive arithmetic definitions. Let's see how we can use those formulas with some application. A high school auditorium has 18 seats in the first row and 26 seats in the fifth row. The number of seats in each row forms an arithmetic sequence. So that means as you go from row to row, we're increasing the amount of chair or seats in each row by the same amount. What is the explicit definition for the sequence? Well, we know that there's 18 seats in the first row. That means our first term is going to represent 18. That should be an A right there. Kind of looks weird. All right, I'm just going to fix that. Here we go. A sub 1 equals 18. In the fifth row, there are 26. So that means a sub 5 for the fifth row, there are 26 terms. Well, we know a sub 1, that's fine, but we need to figure out our d value. How are we going to get that? Let's see. If we start with our explicit formula, a sub n equals a sub 1 plus d times n minus 1, we know that a sub 1 is 18. So we know that's true. We also know that if we have the fifth term, that means if I plug in 5 for n, that my answer is 26 because that's the value of the fifth term. So if I leave everything else as is, look at that. The only variable we have left is d, and that would be the common difference. We need to know that in order to write the explicit definition. Let's move that 18 over by subtracting it, and that would give us 8 on that left-hand side. Now d times 5 minus 1, well 5 minus 1 is just 4, and that would be 4 times d. If we divide both sides by 4, that will simply mean d equals 2, which means in each row we're adding 2 seats. That's not too bad. But again, we're asked to ultimately write that explicit definition. So I'm going to take this orange over here And I'm going to plug in 18 for a sub 1 and 2 for d. Here's what it'll look like. In any row, the number of seats can be found by 18 plus 2 times n minus 1. Let's simplify this formula by eliminating the parentheses and combining like terms. 18 minus 2 is 16. That means a sub n would be 2n plus 16. N is the row you're in, and this formula determines how many seats there are in that row. So how would this be helpful? Let's answer the second question. How many seats are there in the 12th row? Well, that means n equals 12. So instead of having to count from that first row and adding 2 each time to generate the pattern, if we want to find a sub 12, we're plugging in 12 for n on the left side and the right side. 2 times 12 is 24, and 24 plus 16 is 40. There are 40 seats in row 12, based on this pattern. If the 15th term in an arithmetic sequence is 170 and the 20th term is 240, write the explicit rule or definition for the nth term, which is basically that formula in orange up above. All right, so here's what we know. We know the 15th term is 170. That means a sub 15 equals 170, the value of that 15th term. A sub 20 means the 20th term, and that's all the way up to 240. To write the explicit rule, we need a sub 1 and d. So let's first see if we can find the value for d, okay? We'll find d first. So if a sub 15 is 170 and a sub 20 is 240, to figure out the common difference, what we're going to do is just apply a little definition. Take the last term you know minus the first term that you're given. So just basically like the difference between those two terms, divided by how many terms there are. So in this case, our last term is the 20th term, it's 240, minus the first term that we know is 170, that's the 15th term. How far apart are those two terms? Between 15 and 20, there are a total of 5 terms between them. So now we just simplify. 240 minus 170 is 70, divided by 5 equals 14. That means we're adding 14 each time. That's how you find the common difference. Then we need to figure out a sub 1. And to figure out a sub 1, we're going to have to use the explicit formula. I'm going to start with a sub n equals a sub 1 plus d times n minus 1. I'm going to change my d, that looks goofy. Let's fix that. There we go. Well, it's not a lot better, but we'll take it. All right, so what we know d is 14. I'm going to plug that in. Then I'm going to take either the 15th term or the 20th term. It really doesn't matter which one you pick. I'm going to pick this one. So this means when I plug in 15 for n, like so, I'm going to use 170 for my answer on the left-hand side. The 15th term is 170. So if I drop down that a sub 1, now that's all I have left to calculate. See how this works. In this parenthesis right here, 15 minus 1 is 14. So now I have 14 times 14 on that right-hand side. Well, 14 times 14 is 196. I have 170 on the left equals a sub 1 plus 196. How do we get a by itself? I'm just going to subtract 196 on each side, and I totally ran out of room. We'll arrow that up on and over here. 170 minus 196 means a sub 1 equals negative 26. In order to write an explicit formula for an arithmetic sequence, we need a sub 1 and d. And now we have both. Let's go ahead and substitute those in to our formula. A sub n equals a sub 1 plus d times n minus 1. We're going to keep a sub n because we want the rule for any term now, not specifically the ones that were given in the original problem. A sub 1 is negative 26, plus our common difference is 14 times n minus 1. We just clean this up by distributing 14 in. Whoops, negative 26. Get that in there. And then plus 14n minus 14. Last but not least, combine your like terms. I'm going to slide this over just a little bit more to the right. Hopefully you have enough space to write this. Our formula for any term in this sequence would be a sub n equals 14n minus 40. That could give you the first term, the 15th term, the 20th, any term you want within that arithmetic sequence. Here's one more for the first part of 12.2. If the fifth term of an arithmetic sequence is 33 and the common difference is 5, what is the first term in the sequence? And then what is the 12th term? All right, well, what do we know? We know common difference. That's a great start. That means d equals 5. We want to know what is the first term. So what is a sub 1? We'll do the same thing that we did up above. We'll use the explicit arithmetic definition, a sub n equals a sub 1 plus d times n minus 1. We know d is 5. That's great. What else do we know? It says the fifth term is 33. That means a sub 5 equals 33. So if I plug in 5 for n, that would be 5 minus 1. That means my output has to be on that left-hand side. 33 equals a sub 1 plus 5 times 5 minus 1. Well, 5 minus 1 is 4, and 5 times 4 is 20. Oops, equals. Hang on. There we go. To get a sub 1 by itself, we'll literally just subtract 20 to move it over. And just like that, a sub 1 equals 13. There's the first part. But then it says, what is the 12th term? Well, let's see what we can use with our given information to help with that. If we want the 12th term, that means we want a sub 12. So a sub 12 would equal a sub 1, which is 13, plus d, which is our common difference of 5, times n minus 1, which is 12 minus 1. All we need to do is simplify that right-hand side. Oops, that's a 12. Oh boy, you think it would be easy to simplify the right-hand side. I can't even write the left-hand side. There we go. All right, 13 plus 12 minus 1 is 11, and 11 plus 5 times 5 is 55. That would mean that our 12th term, if we take 55 plus 13, wow, I'm really struggling, we would get 68. That is the value of the 12th term. This is all the first part of lesson 12.2.